Then I told you. If you want the ACL to take effect in the future, you must mount it under the interface, also called calling. Because in the end, whether it is deny or permit, all need to be done through the interface. So we're going to start looking for interfaces now. 01 interface of R1. Let's take a look at the configuration. Interface E01. After entering this interface, we're going to enter a command that calls IP access group. We'll just put 100 here. After that, here is a direction. There is an inbound inside and an outbound. They are packets in the incoming direction and packets in the outgoing direction. We enter in here and it's okay. After typing, let's use PC1 to ping, or this command. Let's go to ping 20.1 again. It doesn't work. And not only, it also shows these here. It means, now, it is denied through some behaviors configured by the administrator. It is an unusual communication situation. This is before being denied by the administrator. This is normal communication. Now this is a communication denied by us. So above this is what we are talking about, advanced ACL. Next, let's briefly talk about the basic ACL configuration method. Let me demonstrate the configuration command. I won't give you an example for the scene. For the back, because the number I entered is 10. Then it is a basic ACL. Everyone can see. I enter permit in the back. We can do some configuration. Then let me show you. This is the host. This is any. Let's not talk about it. Let's talk about this segment. For example, I have entered the 192.168.10.0 network segment here. I can enter a 24-bit mask here. But we can enter a question mark before entering. You will find there is a thing called wildcard bits. This is a wildcard. We mentioned wildcards when we talked about OSPF. EIGRP and OSPF use anti-masking. Subnet mask is called positive mask. But in addition to the subnet mask and the reverse mask, when we make the announcement, we also have a close one called wildcard. I enter a bar 24 here. After entering this command, show access list 10, you will find I released a 10.0 network segment here. Then it writes a wildcard 0.0.0.255. You see, although I input a bar 24 forward, but it writes 0.0.0.255. Let me give you another example to explain what this means. In fact, for the current wildcard scenarios only in the first contact in the ACL, you will have more understanding in the future. When you get in touch with each other slowly. We are just talking today. For example, I enter another command. Access list 10 permit 192.168.1.0 0.0.0.254. Then I enter another command 0.0.254.0. You'll find I can still type in. Let's check. I have now entered 3. This is the basic ACL configuration mode, followed by wildcards. Let's see. The first is 0.0.0.255. The second is 0.0.0.254. The third is 0.0.254.0. This looks weird. Let's talk about this. Because we actually use less basic ACLs. So wildcards are more worth talking about. Let's talk about this. First, for the mask. Mask is the 24-bit mask we say every day. A configuration where we assign addresses to interfaces 3, 255 and 10. It is made up of consecutive 1s and 0s. And it must be 1 first. Then 0 after. Cannot be preceded by 0. Because 1 means an exact match. An IP address plus a subnet mask can specify a network segment. Then the subnet mask is 1 is the network bit. A subnet mask of 0 is the host bit. It is mutable. All the network bits we stipulated are filled with 0. This is the address of a network segment. So the mask must be consecutive. Can't be out of order. Continuous means it has to be 11110000 instead of 110101. Then the anti-mask we said before is turn this 0 into a 1 based on the mask. Then turn 1 into 0. Just like we talked about the OSPF announcement earlier. The original 24-bit mask declares a network segment. Should be 24-1. Then 8 zeros. When we declared it was 24 zeros and 8 1s. Its anti-mask is composed of consecutive 0 and 1. And 0 and 1 cannot be out of order. Must be preceded by 0. 1 after. This is called anti-masking. Then, for the anti-mask. It is actually such a relationship with the positive mask. Exactly the opposite. So what will use the anti-mask? Just like OSPF and EIGRP. All anti-masks are used. We're talking about wildcards today. Wildcards are the only thing we will touch this concept in ACL in the NA phase. Called wildcards. We call it the jump mask. Pay attention to my words. It is composed of discontinuous 1 and 0. And it is for us. 1 is random. 0 is an exact match. 1 in the mask is an exact match. 0 in the anti-mask is an exact match. Then 0 in the wildcard is an exact match. This might sound a little difficult to understand. The latter two as examples. The first one is too regular, so don't look at it. Let's calculate the two harder. First look at 192.168.1.0. Its wildcard is 0.0.0.254. 0 means it is an exact match. This 0 means that the first 8 bits are all 0. The first 8 digits represent 192. It is fixed. Let's just say. In fact, we don't need to be so clear about the realization stage. But you have to understand. Now the first 3 digits are all 0. Represents 192.168.1. This is an exact match. Then the next bit is 0. It's actually 8 zeros. 000000000. This 254 is 255 minus 1. The last of these 8 bits is 1. So 254 should be 11111110. Now corresponds to this bit of 0. Represents an exact match. The first 7 digits represent any. The last 0 is an exact match. So when we calculate, let's see what changes these 7 can bring. Let's say a few simple. Here side can be written as 00000010. 0 is the last digit. Is precise. This bit can become 1. Then I add 1 up. Becomes 00000100. Further down it becomes 00000110. The last digit is fixed to 0. This bit actually changes between 0 and 1. Actually, at the beginning, this bit can be 0. To us. If it is 0, represents 0. If here is 1, represents 2. If the previous digit is 1, represents 4. If these 2 bits are 1, it represents 6. So, if you write wildcards like this, what it actually matches is from 192.168.1.0 all even numbers up to 192.168.1.255. It matches actually all even numbers. Because for the entire 8-bit binary, 128 from the first, 64, 32, 16, 8, 4, 2, 1. Only the last digit is odd. So if the last bit is fixed to 0, then it means that, no matter how the previous numbers are combined, it is impossible to calculate an odd number. It is always even. So if we use the last digit is 254, then it represents, in this range, you will match all even numbers. As the name suggests, if I change the last bit to 1 here, then you will match all the odd numbers here. Because this one will always take the value. No matter how the above even numbers take value. Just add an odd number at the end. It's an odd number. In fact, it is not very useful at this stage.